Welcome to the Explainer. Today, we are digging into a number that has a surprisingly huge impact on how fast a website feels. 14 kilobytes. It really doesn't sound like a lot, but as you're about to see, it can be the difference between a site that feels instant and one that doesn't.
Yeah, this quote from an engineer at Netflix really gets to the heart of it. It hints that this isn't some smooth, gradual slowdown. It's more like you're driving along and then, boom, you fall right off of performance cliff.
And, look at this. It really is a cliff. Going from 14 kilobytes to just 15 can slap on more than half a second of load time. But then adding another kilobyte after that barely makes a difference. So what is so magical about that 14 kilobyte number?
Right. This is the big question. It makes no sense on the surface. How can one measly kilobyte cause such a gigantic delay? Well, the answer is buried deep down in the plumbing of how the internet actually works.
So to figure this out, we've got to unpack a process called TCP slow start. It sounds a little technical, but it's the foundation for how most of the web gets to you. So TCP's number one job is to be reliable. And when you ask for a web page, you want the whole thing, right? Not just a few pieces. TCP makes sure that happens by having your browser send back these little confirmation messages. They're called ACKs for every batch of data it gets.
But here's the thing. When you first connect to a server, it has no clue what your internet is like. Are you on super fast fiber, or are you on a shaky 2G connection in the middle of nowhere? To be safe, the server uses this algorithm called slow start. It doesn't want to just blast data and break things, so it starts slow.
And this process is all about being cautious. The server sends out a safe, initial batch of just 10 packets. Then, and this is the crucial part, it stops. It literally just waits. It needs to get that OK message back from your browser before it feels confident enough to double down and send more. Each of these pauses is called a round trip, and they're the real culprit here. So how much data are we even talking about in one of those packets? Well, after you subtract all the space for the headers and other protocol stuff, you're left with about 1460 bytes for your actual website content.
And right here, this is where it all clicks. You take that initial burst of 10 packets, you multiply it by the 1460 bytes you can cram into each one, and what do you get? Just about 14 kilobytes. If your whole site fits inside that first shot, it all arrives in one go, before the server ever has to pause and wait for that first OK. So going over 14 kilobytes forces that pause, that extra round trip. And this brings us right to the cost of latency. Because the next question is, just how much time does that little pause actually add? It's a totally fair question. You're probably thinking, come on, how long can that possibly take? It's just a tiny little signal going back and forth. Well, the answer might surprise you. It can take a long time. To get why, you have to separate two ideas in your head, bandwidth and latency. The classic analogy is a water pipe. Bandwidth is how wide the pipe is, how much water can flow through it at once. But latency? Latency is how long the pipe is. It's the time it takes for one single drop of water to get from the start all the way to the end. And our round trip is all about the length of that pipe. Let's use an extreme example from the source material just to see this in action. Imagine an oil rig worker using satellite internet. The signal has to leave the rig, travel 35,000 kilometers up to a satellite in space, come all the way back down to a station on the ground, and then travel through fiber to the server. And remember, that's only one way. The little ACK message has to make that entire trip in reverse. So when you add all those milliseconds together, you get a massive 612 milliseconds, over half a second. That is the penalty. That's the time you pay for that one extra kilobyte that pushed your site over the 14 kilobyte limit, because it forced that second round trip.
Now I know what you're thinking. Okay, fine, but I'm not on an oil rig. And that's fair. But high latency isn't just for satellites. Think about old 2G and 3G networks. Or what about the Wi-Fi at a crowded concert or a coffee shop? Even just a spotty connection at home that keeps dropping packets. All of these everyday situations can easily add hundreds of milliseconds of latency to every single round trip.
All right, we've gone deep on the why. Now let's get to the important part, the how. How do we actually put this 14 kilobyte rule into practice? So here's some really good news.
That 14 kilobyte target is for the data after it's been compressed with something like gzip. And this is a huge deal. It means that 14 kilobytes of compressed data could actually be 50, 60, maybe even more kilobytes of your original code. So the target is more achievable than it sounds.
The whole strategy here boils down to one thing: being absolutely ruthless about what you send first. Your entire goal is to get something meaningful on the screen inside that first 14 kilobyte burst. This means you do things like inlining the most critical CSS, making sure big images or scripts load later, and being really careful about big, heavy frameworks in that first payload.
Okay, but this is a question I had too. You know, technology moves so fast. We've got these newer, smarter protocols like HTTP/2 and HTTP/3. Surely they fixed this by now, right? This has to be an old problem.
Well, the source material is crystal clear on this one. Nope. The problem is so fundamental to how you safely start a conversation over a network you know nothing about that even Quick, the shiny new protocol that powers HTTP/3, still recommends starting with that same conservative 10-packet window. The rule is here to stay.
So what does all this mean for the future of building things for the web? It turns out this little technical detail points to a much bigger idea, that the future, in many ways, is still small.
I just love this quote. It puts everything in perspective, doesn't it? I mean, there are coding competitions where people build entire playable 3D games like Quake in just 13 kilobytes. When you see that, you have to take a hard look at your 2-megabyte marketing page and ask, really?
And we'll just end with that question. Because thinking about this 14 kilobyte limit isn't just a technical exercise, it's a design philosophy. It forces you to define what is absolutely positively essential for your user's very first impression. What information, what button, what feeling gives them the most value in that first fraction of a second? Answering that question is the real secret to a fast experience.